All right, everybody, we are in for a treat today talking about area. I want to run through three different situations that are kind of different than just finding the normal area between two curves and see what it looks like here. So I've got a region shaded, and I want us to pay special attention to anytime either the top function changes or the bottom function changes, and so that occurs right here. So if we're going to integrate or find the area under or in between two curves, and either the top or the bottom function switches, right, we are going to have to split it up into two regions here. All right, and so our first region is going to start at the origin. It's going to start right here, and it's going to stop when we get to x equals a. And so here's what our first integral is going to look like from 0 to a. And whenever we're getting the area, we always want to do top minus bottom. But in this region, the bottom function is 0, right? It's the x-axis rather. And so the top function is f of x. And so I'm just going to put f of x right here. Okay, that's our first part. Again, there's a top function, the bottom function is 0. For this next portion, we're going to start at a right here. And then we're going to stop at this intersection. We want the x coordinate from there, so we're going to stop at b. But in this portion, there is a top and a bottom, and so the top function is still f of x. The bottom function is g of x, and so if I want the area between those two functions, I'm just going to subtract. All right, so this works. I do want to show you guys, you most likely won't have to calculate anything this way, but occasionally there's a multiple choice question on the exam where the answer looks like this, and so I want to just briefly talk about this. Using dy, we don't think about breaking it up vertically like I did here. We think about everything from left to right. So think about everything horizontally here. And if I draw a horizontal line anywhere on this graph, just draw one right here, etc. G of x is always on the right, f of x is always on the left. So it never switches which function's on the left or which function's on the right. Okay, so if we want to do this one, with respect to y, we're going to go not from left to right with our bounds, but from bottom to top, and we're going to take the y coordinates. So the bottom y coordinate is down here at 0. The top y coordinate is up here at c, and so that's going to be our bound from 0 to c. We're not thinking top and bottom, we're thinking left and right now for what goes in here. So we're going to put the rightmost function first minus the leftmost function, so g minus f, but we can't write g of x and f of x. It would actually be g of y minus f of y. And what that means here is if these were actual functions, like if g of x was equal to x minus 4, we're going to have to solve this for x. And so I'm going to make this a y, right? And so y plus 4 equals x. So this is what I would put in for g of y plus 4 for this question. And again, this may not actually be the exact equation. I was just kind of going through a hypothetical here. If f of x was like a natural log of x, right, we're going to have to use our exponential properties to somehow rewrite this to solve for x. Okay, so again, I'm not going to go over that. That's not the focus of this video here, but just keep that in mind. If we're using dy, we have to solve for x in the equation, and then that's what g of y or f of y would be. All right, so that's our first case. Let's look at this one now. And so we're going to go from left to right thinking vertically. And so we're looking for times where the bottom function switches or the top function. So the bottom function on this graph is always 0, but the top function does change at this intersection. From here to here, the top function is f, and then the rest of the way the top function in this section here would be g. So again, we're going to split it up right here into two regions. The first region is going to go from x equals a to x equals b, x equals a to x equals b. The top function, right, if we want the area under the curve, the top function is f of x. There is no bottom function because it's the x-axis. Okay, so for this first region, it's just the top function. And then here, there's still no bottom function. The top function is going to be g of x, so g of x. and our bounds would go from B to D. Okay, so I'd split it up like that. If we wanted to do this as a dy, again, we could do that as well. If I wanted to put that back, if I wanted to do this as a dy, I would think I would go from bottom to top thinking horizontally, and so the right function is always over here, and this is always the left function. So again, the right function, left function. So I can do this all as one interval. Bottom to top would go from 0 to c again, and this is just like the last one. G of x was the right function, or g of y, minus f of y would be the left function. All right, last one. The top and the bottom are going to switch here. So we're going to split this up into two intervals. Again, from left to right, our x coordinates are A and C, and then C and E. So we're going to go from A to C, and then from C to E. Now, and we're just going to do this one dx. It's not worth it to do it as a dy, because you're going to have a few things going on here. So again, I'm just using the x coordinates A, C, and E. And in this first region, again, to get the area between the two, we're going to do top function minus bottom. So it would be f of x minus g of x, f of x minus g of x. And then in this second region here, it switches. So g of x is on top, f of x is on the bottom. So we're going to do g of x minus f of x. All right, so that's it for this. You guys should be able to do the practice now, and it will put actual equations on most of these types of questions here, where you can come up with answers either calculator or non-calculator. You might just be setting it up, or you might be, again, actually taking an antiderivative by hand or using the calculator. All right, that's it. Stay flawless.